Hello, and thank you for joining us for this Hagley History Hangout. I am Gregory Hargreaves, Program Officer in the Center for the History of Business, Technology, and Society, the Hagley Museum and Library. And I am being joined for this History Hangout today with Salem Elzway, a PhD candidate in the University of Michigan, who has conducted research at the Hagley Library supported by an exploratory grant as well as a Henry Belin du Pont research grant from the center for his dissertation project, which is tentatively titled Arms of the State, A History of the Industrial Robot in Postwar America, which examines the political economy of industrial robots between 1940 and 1980, seeking out the ways social forces shaped the developing of the technology and how the novel technology reshaped society in turn. State policies concerned with military power and economic productivity intersected with the work of an array of other actors to develop and deploy industrial robotics. And I'm really excited to talk to Salem about that today. Thank you so much for joining me.
Thanks for having me, Greg. I appreciate it.
That's great. Well, let's sort of dive in from the main subject here. What is an industrial robot, or what are industrial robotics?
That's actually one of the major questions that kind of inspired the research. And to be honest with you, I'm still working on an answer to that question. Just like many technologies and other kind of social processes, the definition of what it is you're looking at changes and shifts over time, depending upon who you're talking to, how this technology or the forces it's interacting with, what exactly it's doing. So in the case of the industrial robot, the term itself really doesn't really come to fruition until maybe the mid 50s to the late 50s, and then becomes popularized in the 60s and thereafter. Up until that point, typically robots were seen as, science fiction entities. They're usually concerned with kind of humanoids or the anthropomorphized version of the technology itself. Probably most popularly in the American imagination, seen with Electro at the 1939 World's Fair, which was a giant, 7-foot robot that could smoke. It could answer, limited questions and things like that. But the idea of a robot as mostly an arm, a mechanical arm that is moving, products around, doing materials handling and assembly, that takes a few decades to kind of become the normal version of what we think of to be an industrial robot.
And so we would say this automatic armature is, you would say, a default configuration for industrial robotics?
Yeah, essentially what happened is that what we think of to be the industrial robot came from about 3 different major technologies.
Okay.
One is numerical controlled machine tools. Another is teleoperated manipulators that are being used at the end of the 40s to handle nuclear and atomic materials, since they're so hazardous and difficult. And then, of course, digital computers. And essentially, you put those 3 different technologies together, and that makes what people consider to be the industrial robot as one kind of technological system. And essentially, since that period in the late 50s, the industrial robot kind of emerged from those technologies and became its own kind of standalone system. And even until today, most of what we think of to be industrial robots are single large mechanical arms that are working within work cells or on assembly lines that are moving and assembling parts together. Not until about 1974, I believe, give or take, the Robot Industries Association came up with an actual definition for the industrial robot itself, specifically about its programmability, about its ability to actually interact within its environment, have some sort of what artificial intelligence people would say, some sort of knowledge or intelligence about the environment it's working in. However, it kind of took some time to come to the conclusions about what that definition was and what it meant. And one of the interesting kind of things I found in my research is by the late 70s, early 80s, of course, Japan as a national power is becoming a little bit more of a concern to American manufacturing because of how competitive the Japanese were. And one of the kind of issues they brought to the fore is that Japan is much more adept at using robots in their manufacturing facilities. However, the Japanese defined robots in a very, very different way than what the Americans did. And what the Japanese actually defined as a robot had about 3 categories that Americans would not define as being robotics. They would just define it as other forms of automation. So what happens is that the numbers of Japanese robots gets inflated, right, in a lot of the congressional discussions and even in trade associations and by companies, which is interesting because they can use that as kind of a rhetorical piece to try to convince manufacturing in the American state to provide more support to robotics, because up until this point, robotics is seen as the most advanced form of automation, and it's going to be the most advanced form of productivity, to create productivity, I should say.
Well, what were the social forces conspiring to bring these 3 streams of technology together, and to sort of prepare the ground, if you will, for the adoption of industrial robotics?
Sure. A lot of this, I mean, if you're going to oversimplify it, we could talk about it in terms of the military industrial complex, which is obviously a popular way of describing a lot of technological development in the United States. And what's happening is that in essentially the mid 40s, give or take, you start to see a lot more of an approach towards manufacturing, what we call automation, into digital realms as new computing technology is coming to the fore. Particularly, this is where the numerical controlled machine tools are coming into play. In about 1945 or 1946, the gentleman who is typically seen as being what we would call the father of industrial robots, his name is George Devol. He actually patents a product that is essentially a numerically controlled machine tool. What he does is he applies essentially a control device with a memory system and then attaches a mechanical lathe to it, and then essentially leads this lathe through a particular motion and then stores that on the memory system, and then you can just hit the button and it repeats that over and over. Which is, of course, this is a continuation of a long tradition of machine tools and what we think of to be the American system of manufacturing, using all kinds of jigs and fixtures to create interchangeable parts. And this is a little bit more of an advanced process in terms of metalworking for more difficult kinds of processes. So starting in the mid 40s, you start to see the development of what we consider to be numerical control. And of course, the big project comes out of the Air Force and the MIT in the late 40s and early 50s. Much of this is discussed in David Noble's book, Forces of Production. So as a quick historiographical aside, my dissertation, I kind of look at it as a follow-up or a sequel to Noble's Forces of Production, because he does actually talk about industrial robots to a limited degree. But because he was so focused on numerical control machine tools, the industrial robotics aspect was more of just kind of an interesting example and comparison that he used. So what I wanted to do in my dissertation is say, like, well, okay, what happens after numerical control machine tools? Because the idea was essentially that these industrial robots are going to be that next technology. So even in this kind of rambling presentation, you can see that you have the manufacturing industries that are going to be very interested in robotics in terms of creating new forms of productivity, more specialized products. You have the military that's involved because the vast majority of military hardware at this time is particularly going into aerospace, and the aerospace industry is going to be the primary users of these numerical control technologies, and eventually industrial robots are going to fulfill that purpose as well. Now, what industrial robots provide that's outside of per se just military production that goes into more general manufacturing, particularly in the automobile industry, is that they have the capability to have all different types of tools attached to them. It's not just necessarily a lathe or a machine tool that's doing metalworking production. You can actually have all different types of tools that are attached to these robots, and because of their general purpose kind of capabilities of movement and being able to be restructured in the production process, that they can assemble, they can handle materials, they can do all types of different jobs that a machine tool is not designed to do. So in this case, you have all different types of sectors becoming very interested in using this technology. Now, during this period, one thing that becomes like very interesting is that the industrial robot, in terms of its cost and effectiveness, it takes a while for that to actually kind of seep into industry, because between the end of World War II and the starting into the early 1970s, we look at this as being the golden age of capitalism, particularly in the United States. And one of the reasons why is because you have the tripartite kind of political economy of big government, big business, and big labor. And the kind of forces that existed at this time, labor itself was still cheap enough that it's just better for an industry to just hire a worker to do the work than to invest so much into capital goods like an industrial robot. It wasn't until labor became much more expensive and productivity numbers are going down, profit margins are going down by the late 60s, that then business becomes much more interested in actually implementing these advanced robotic technologies, because they're seeing it to be very profitable for them. And to actually, to a sense, what Noble got into in his text is the idea that numerical controlled machine tools were designed in a certain way to privilege management over labor, so you can essentially undercut union power and collective bargaining. That by structuring the technology in a particular way, designing it in a particular way, what it does is takes the power out of the hands of the worker to control that machine and puts it in the engineering and manager's hands. Now, in the case of the industrial robot, you're doing something actually completely different, because you're getting rid of a worker completely. So this has all kinds of ramifications that become really interesting, because the robot itself is being developed in the 50s and the 60s, at least its early form, in a period where automation and cybernation, as a popular term was being used at the time, is becoming a real big political issue, where people are, or I should say the American public is seeing automation throwing people out of work and not seeing any type of redress in terms of the labor movement about how they're going to deal with this notion of technological unemployment, and that robots would just be a continuation and an acceleration of technological unemployment, which of course becomes more and more an issue each decade as the technology becomes more and more advanced.
How does the technology become adopted in sectors outside of aerospace and automobiles? It seems like it makes sense to begin there, because your engineering requirements call for a higher level of precision, and you're also producing very high value goods. So I think I see how it's a clear fit with those sectors. How does it get adopted by other industries?
Sure. A lot of this is actually going into industries that are doing mass production. That's one of the big differences, obviously, with aerospace, is that's mostly small batch production. You're doing very highly specialized products that require a lot of skilled labor. The International Association of Machinists were very involved in the development of robotics as well, particularly into the late 70s. They're becoming much more involved with this. And the movement into automobiles makes sense because it's high volume production. But of course, in metalworking, it still does require a higher level of precision to kind of create those products. Now, other industries, for instance, one of the uses of the robots earlier was in a brick factory. And it's a very high volume product that's very easy to produce and move around. But of course, for workers, that's a heavy kind of difficult job to be doing. So it makes sense to do a lot of implementation application robotics in those kind of fields, because one of the major uses of robots from the beginning is doing a lot of materials handling and what is just called in manufacturing industry palletizing. So to move products, whether they're raw materials, semi-finished good or finished goods, into the factory, throughout that factory space, to be doing the manufacturing process and then move them out for distribution and consumption. It makes sense to create a much more kind of standardized form of stacking and moving those things, and this is called palletizing. And that's a lot of what actually early robots did, is that the actual design of product movement was redesigned so that robots could actually move those around the factory floor. The first major use of industrial robots, particularly in the automobile industry, is in die casting. So it's moving very, very hot metal molds from place to place, and that's a difficult job for a human to do. So anything that involves these kind of what were called hot, heavy and hazardous jobs is essentially what was being implemented. So automobiles, the brick factories, General Electric early on used prototype robots to essentially move and sort lots of light bulbs. So to just complete repetitive processes that are just happening over and over again is usually what's going to be most beneficial for the application of robotics in this period. I'm trying to think outside of that. One of the more advanced uses of robotics once you get into the 70s, this is more when robots are actually becoming much more intertwined with microelectronics and with advanced digital computation, and particularly with vision systems that are being developed, is General Motors actually use one of their most advanced robots in their integrated circuit boards. So what they would do is actually have advanced robotics, where the printed circuit would come out, it'd have to actually go down a conveyor line. And instead of having a human place those they're in an appropriate place, they'd have a robot with a video camera that would reach down and appropriately line up the chips so that the next form of the production process could be much more precise and not have to worry about the human integration with it. So integrated chips became a big part of this. That's one reason why, for instance, Texas Instruments actually developed their own in-house robotics instead of going outside of that. IBM also had a similar program as well that they developed internally. But the latter of those, I'll have to say I'm a little bit ignorant of them. I'm still kind of getting into the research about what those looked like.
Well, let's then come back to the research and what collections did you access at Hagley, and how have they proved useful to you?
Sure. A lot of my work at Hagley actually has to deal with, I wouldn't say a separate aspect of the dissertation, the research, but a different one in terms of the actual technology itself.
Okay.
One of the things I'm really interested in is national security policy and its effects on technological development and the political economy of those issues. And a lot of the literature in terms of national security policy, whether this is in history or political science or security studies, they're particularly looking at the government side of this. One of the reasons why is because documents are available. You know, these are public archives that you can get into, where when it turns to the industrial manufacturing side, it becomes a little bit more difficult just because these are private corporations and the vast majority of them don't have accessible archives that you can look at. So I had to figure out a way, how do I get a clearer picture of what's going on in industry? Maybe it won't be individual companies per se, but I can look at the community broadly. So it made sense to go and look at the National Association of Manufacturers records, you know, since it's the major trade association that's representing a lot of medium to larger sized manufacturing corporations. And then also looking at the Chamber of Commerce records as well, just because you can get a sense of smaller businesses are usually represented by the Chamber of Commerce, since it's a lot more locally based. So I thought looking at Chamber of Commerce and National Association of Manufacturers, I can get kind of a little bit of a feel about how they're looking at, you know, this multi-decade process of how new technologies are being implemented into the manufacturing sector, how automation is being affected by these things, and in particular, how are they viewing national security policy and the government's role in the process of this. Both the Chamber of Commerce and National Association of Manufacturers are typically looked at to be what we would call conservative organizations. They typically are going to be arguing for a smaller government footprint in terms of its effects on the economy, in terms of regulation. And I wanted to get a sense of, okay, does that actually hold up in terms of how they're looking at national security, how they're looking at defense, government expenditures in that realm? You know, get a sense of their ideological consistency. So I was really interested to find out, how does the National Association of Manufacturers, particularly in the 50s and the 60s, when we think of the national security state as really coming into its own, how do they look at these issues in comparison to how they're talking about, for instance, government expenditures for what we would consider to be social programs, you know, welfare programs, social security, and things like that. I wasn't necessarily surprised when I kind of discovered that they did look at national security issues differently. I actually pulled a couple quotes real quick. So the National Association of Manufacturers, this is just a short one. This is from a document in 1952. It's just essentially general, like, short position statements that they had on the federal budget, and they would break it down. They'd have something on taxation, then something on subsidies, and another issue on for instance, like resources. So under their position for subsidies, the very first thing it says is no subsidies except for national security. So it's like a very straightforward position. And one of the reasons behind this, when you actually start to look into the different committees that are looking at national security policy and how the National Association of Manufacturers is going to be integrated into this, is that they recognized that the business community writ large in manufacturing sector specifically, it's very difficult for any individual company or even a group of companies to put the money into the kind of research and development that was required to produce these technologies and to create these kind of weapon systems, if we want to call them that, for the military, that there's going to be some need for the government to step in to do that. And particularly in terms of when you get into what will be called fundamental or basic research, a lot of companies are not going to pay for that because it does not make sense to them to take those kind of risks. The research and development environment requires lots and lots of failure. And of course, a profit-making enterprise can only take so much failure before they can run out of that. Now, in the same period, of course, we're going through kind of a time that a lot of more alternative or leftist political economists are looking at this as what's called monopoly capitalism. Because we have that kind of political economy of big government, big business, and big labor, is that you actually do have the ability of very, very large corporations to take on a large burden in the research and development environment. And of course, there's a long history of this. DuPont is actually one of the first corporations to even develop, in-house laboratories, going into General Electric, and then of course General Motors in the 1930s. And General Motors actually has a very, very large research profile even today, but particularly in this period, the GM Research Labs becomes a really, really key locus of advanced research and development across kind of disciplines. So the National Association of Manufacturers is recognizing that this is a necessity for actually contributing to national security in the United States. And it's also another interesting thing that's kind of a part of my research is that when you start to look at the articulation of what national security actually is, a lot of it is actually just the ability to create new technologies and to advance science in order to support the underlying industrial base. And this is one thing that actually occurs in an interesting shift from the early 60s into the 70s, is that because Eisenhower's notion of the military industrial complex is so heavily laden with kind of political meaning and got taken up so much by many different actors within the American polity, mostly as a pejorative and as a tool to try to scale back the military industrial complex, to use it as essentially weaponize it in terms of trying to get out of the war in Vietnam and Southeast Asia writ large, and as critiques of American imperialism, that what we call the military industrial complex, the term actually within I guess you could say the DC establishment, and then also within the business community, they started to just call it the defense industrial base. And that's actually what today it's still called. And that was like an interesting internal shift. Like, we need to shift the language to call this something a little bit different. And that's essentially what national security policy is mostly about, is about providing a conducive environment for the defense industrial base to flourish. The National Association of Manufacturers in the early 60s, they were very quick to notice how detrimental it could be if the military industrial complex as a pejorative got legs. So they initially, until about the 70s, they were pretty gung-ho about putting a positive spin on the military industrial complex. And they would, have all kind of speaking tours and bring in different people from the military and from all kinds of corporations to give discussions and give talks about like why this was so beneficial to not just national security, but American business writ large. So far, what I've seen in the documentation, by about the early 70s, they kind of gave up on that. Once you start to see the shift in the way this concept is understood from military industrial complex to defense industrial base, it was a way of essentially eliding the negative aspects of the military industrial complex. So there's been some actually really, really great documents and sources I've found within the National Association of Manufacturers, but because their collection is so large, I'm sure there's all kinds of extra stuff that is there to be found.
Would we say industrial robotics were a Cold War technology?
Sorry, could you repeat that? I didn't hear the first part of the question.
Oh, would you say, or would we say that industrial robots are a Cold War technology?
I mean, it's an interesting question. I mean, in terms of how we think of the Cold War as just denoting a particular period in time and space, then absolutely. If we're thinking about it in terms of what the Cold War means, like as a description of a particular like geopolitical rivalry, yes, I think you could still do it. One thing is that the focus of my dissertation is in the United States, and one of the limitations, unfortunately, is that this is actually a global phenomenon, even though the main center of it is in the United States. Essentially, one of the first places to uptake industrial robots is actually in the UK. Most people would think of it being Japan, which comes just a little bit later. But the major, or I should say, the first and largest industrial robot company, Unimation, their first office outside the United States is in the UK, is in England, and then you get an uptake at Fiat in Italy. And then in Germany, and of course the Japanese become a big part of this. But that's mostly just in what we would consider to be the quote unquote Western world. Robotics are also becoming big in Eastern Europe as well, and in the Soviet Union. And from the Soviet Union's perspective, they wanted to be on the forefront of automation technologies, because that's actually how you're going to turn your manufacturing facilities into a fount of goods and products for a classless society. So it makes a lot of sense actually that they want workers to be able to control the modes of production, and pretty much the best way to give workers the most control, but also have the most essentially conducive workspaces for the future kind of Soviet citizen is in the most automated facilities as well. So the Soviet Union's also getting very, very interested in robotics at this time. But I still need to look into exactly why it was that the technology itself didn't seem to advance as quickly or take hold as much as it did in the more what we would call the capitalist world. So in terms of it being a Cold War technology, I definitely would say that it makes sense that the political economy that contributed to its development is definitely associated with the Cold War. One thing that I found really interesting in my research is that, one of my early hypotheses is that my guess was this technology is probably going to develop similar to numerical control tools, because it is a very, very difficult technology to essentially advance. It's very costly. It's essentially made up of all the most advanced technologies at the time. I've been very, very surprised actually how important the military sector, or at least military funding, had been to the development of the industrial robot. So for instance, Unimation, the company I just mentioned, they were actually a subsidiary of a larger conglomerate called Condec, and Condec essentially was just a developer of military technologies, specifically military vehicles, nuclear control systems, and aerospace control systems. So when you actually look at the money that's coming into Unimation, the vast majority of that is from revenues coming from the military sector. Now, Unimation, they are not even profitable for 15 years, which that's a pretty long lead time when you look at any kind of new technology. Most of the time, if we look at venture capital and what those early stages of business is going to be, 5 to 10 years is really the longest you can ever think of until you actually have a product that it's either going to fail or it's going to become a success. The fact that Unimation can take 15 years until they even turn a profit is possible because they're operating under this umbrella of it's a medium-sized defense contractor, but they can put so many revenues into this. Now, this discussion too is completely left out the academic sector, which is a key part of this entire process. And it's actually a big part of my dissertation as well, because so many of the developments that are going into the robot itself are being done at the major academic centers for computing and artificial intelligence, MIT, Stanford, and then at Stanford Research Institute, or SRI, during that time. So there's a whole nother conversation to be had about how the military, industry, and then academia all kind of come together. And that's really the story that I'll be telling in the latter part of my dissertation, specifically in the 70s, because this is really when you get all these kind of different threads that come together and really produce what we would consider to be the modern day industrial robot.
When this issue of automation and of robotics and of artificial intelligence is still with us,
Mhm.
are there any implications for the present or perhaps even the future that you could draw from your work?
Absolutely. I think one of the more interesting things that I've looked into is that, and this kind of actually tails with your question about whether it's a Cold War technology, is that a lot of the relationships and connections between the military and industry and academia, um, we shouldn't be thinking of those as Cold War relics. Those are completely going on today, and to be honest, the shift that's come up until our present time has actually been less about the military spending money per se on what they would use within the field of battle on military technologies and weapon systems. Is that the military is I should say very progressive in terms of what kind of technologies and science they fund. And if you look at, for instance, probably the most popular one that people would know about is some of the DARPA grand challenges in terms of creating robotic vehicles. The actual beginning of the grand challenge goes all the way back to Carnegie Mellon University in 1979, when they started their own robotics institute built upon lots of their AI and computing research, and really got invested into autonomous vehicle technology. And those grand challenges are just a new way of funneling resources into all these different, both academic and private corporations, in trying to advance those technologies, because the military and what I would call the state sector writ large is that they recognize that these technologies are going to be useful not just for any type of military engagements, but for commercial products and what popularly is being called dual use technology or spin-offs that are coming from these processes that are going to be going into the economy writ large. So the military has always actually been at the forefront of technological development in the United States. And I don't see really much of a change in our current day. Even under the Obama administration, they got into, I'm trying to think of what the numbers would be. I believe it's over $1 billion that was laid out for advanced manufacturing. Pittsburgh got one of the new national manufacturing centers. One of the major reasons why is because of Carnegie Mellon and how much infrastructure they had built up for robotics. And then U.S. Cyber Command is in Pittsburgh. So pretty much the home of advanced software development is in Pittsburgh. So it makes sense if your manufacturing processes in the future are going to be dependent upon artificial intelligence or robotics to locate state-funded sectors there as well. And it's actually interesting that in my interpretation, it's that the actual role of the state has been much more constant than what the historical record has really shown. And one of the, I guess, approaches I take to my own work is that most of the time we think of history as the study of change over time. And I kind of am more interested in looking at what is the continuity over time, kind of what are the things that are staying the same and why is it that those things are staying the same? Or in terms of how we look at change, how much of a change actually is it, right?
Salem, thank you so much for talking with me about your work. This is just really fascinating.
No,
And
thank you for having me. I appreciate it. It was a really good conversation.
I think so as well. And for our audience, if you would like more Hagley History Hangouts, please go to our website at hagley.org. That's hagley.org. And for more information about the Hagley Center for the History of Business, Technology, and Society, and our research grant and funding programs, you can find that on the website as well. Thanks once again, Salem, and thank you for joining us.